Okay, in this video we're going to go over the answers for the quiz and the basic networking quiz that shows up in learning modules, quizzes, exams, and basic networking. So we're just going to look at the answers, which I don't think the students can see this. Okay, and these were shown in a random order, so this is not necessarily the order that you would see them. I'll just go through. Okay, so how many bytes are required for a MAC address? That you could have, so the answer is 6, and you could find this by looking at Wikipedia, or you could find this by starting up Wireshark. MAC for media access control. Okay, so in any one of these, if you look in the Ethernet field, then the source and the destination, each one of these is 6 bytes. How many bytes are required to store an IP version 4 IP address? So for that, you would look under IPv4. And in the IP address, so here that's already correct there. There's 4 bytes. Each byte is 8 bits, can be 0 to 255. So that's 4 bytes. And if you look in the this is talking about IP version 4 or 6. So here's the 32 bits. We'll leave it at that. Over in Wireshark, you would see Internet Protocol version 4. And if you look inside of that, one of the fields here is the source and the destination. So the source there is 4 bytes. Destination is another 4 bytes. Alright, number 3 here, how many bytes for an IP version 6 IP address? 16, and you'd have to look in IPv6. So here it says 128 bits. That is 16 bytes. 16 times 8. 128. Okay, and if you looked up in IPv6, you would see this in the packet format. IPv6 packet. You can see a picture of this where you have the source address, and each row here is 4 bytes, and you have 1, 2, 3, 4 rows. That's 16. Okay, number 4. IP version 6 improves on IP version 4 by having headers that are smaller. That's false. IP version 4, the header here is 8, 10 rows, and version 4 was 5. So it's definitely larger, and it's because of the source and destination addresses are longer. This was a question where it said if you have so many bits to store an IP address, how many IP addresses are possible? And the answer, so this was chosen at random, and the answer was 2 to that power. So if it asked you for 3 bits, then the answer would be 2 to the 3rd. It would be 2 to the 3rd, or 8. So if I had 3 bits, those are all the possible values that 3 bits can be, and there's 8 of them. And in general, you have this formula 2 to the power and the number of bits. This question, number 6, was asking if you're going to use Telnet and Wireshark to look at what the TCP/IP traffic looks like, then what are the steps? And this was specifically asking for Telnet. Some people said to use your browser, so I was asking for Telnet. Let's just go ahead and give a view with CNN.com. Okay, so first step is to get the IP address for CNN.com. We're supposed to start up Wireshark and then put in a filter for that IP address. I'm going to restart so that we just see the request to CNN, and then we need to telnet, and we need to put the port in. So with the version that I have here, telnet CNN.com port 80. So a lot of people didn't mention that you have to use port 80, so that's what the web server is going to be listening for. And then you do your get. And I didn't get anything. But so here's the traffic. And the response was, so these are synchronize, acknowledge. Then we have my get request, so there's some more synchronization. My get request, and the response from CNN was that the page had moved. So you can try to read that if you want, but so that was the response. Alright, so those steps there, the one that most people missed was that you need to do port 80. And I gave you, if you just missed one item, then that was -1 point down to, some people got 2 or 3 depending on how much you missed. Alright, number 7, matching. What did these Linux commands do? Who is usually used to look up information about a server, and that's this information here. It has the name servers. ifconfig shows information about the network adapters and network. Okay, so these are the network adapters and the network EN0 and EN1 are the networks on this computer. I think EN1 is the one I'm using right now. There's the IP address of my computer. Ping, test the connectivity. Trace route, give an estimate of the number of hops. So that wasn't much to get to CS. And host name, what is the name of the current computer that I'm logged into? This is an ISU laptop that I'm on right now. Okay, number 8. Place the following protocols in order, and I allowed it in either order. These were displayed in a random order, different for every person, and I allowed the lowest level on the top or on the bottom, either way was okay. So if we start on the top, HTTP is the text that I typed in to Telnet. TCP is the protocol that sent that text. IPv4 is the protocol that sends that the TCP is inside of. And Ethernet is the connection from my computer to the local router. And this one here was something new we didn't talk about, but the actual bits have to be sent somehow on the wire. So the Ethernet says which bits are going to be sent, and then there's some encoding about a 1 is a high voltage or a low voltage or that type of thing. So all of those except for the number 1 there you can see in Wireshark. So you have Ethernet then IP, there's the Ethernet. Inside of that is the data of the Ethernet packet is an IP packet, and the data of the IP packet is a TCP packet, and the data inside of that TCP packet is the HTTP request. Number 9, OSI model is not as commonly implemented. You just needed to look this up. We haven't talked about the OSI model. OSI is a different way to organize the layers. And so these are the layers in the OSI model of looking at networking. And some operating systems have actually implemented things this way. We've been looking at the TCPIP stack, which is much more common. Okay, number 10. The version of an IP packet can be determined by looking at a field in the header. That's true. If you're looking in Wireshark, the first 4 bits of the IP packet is the version 4, and it would be 6 for version 6. And if you look on Wikipedia, you'll see that as well. Okay, number 11. This was looking up DNS servers, and the command for that is whois. So if we do whois cnn.com, we said one of them ends in .org, one of the name servers. All right, hold on a second. Okay, the version of whois that I was running on my laptop here wasn't showing what I wanted. I'm just logged into CS now, and you could also have used an online whois to find the same information. But we're looking for cnn.com that ends in .org, and if you do whois on CS, there's name servers, and this is one that ends in .org. There's a 1086 and an 07 in there. There's a 1086 and an 07, so that was the one we were looking for. Same question about MIT with which one has a 37 in it. So these are all name servers. There's one with the 37, NS1-37. Okay, number 13, UDP is reliable in order. That's false. TCP is reliable and in order. UDP is not reliable and not necessarily in order, but it's more efficient, less overhead. Number 14, what is the IP address of CS? So if we just do ping CS 139.102.14.201. Same question for X1. If I didn't happen to be logged into CS, I should get the same answer, 139.102.14.205. What is the broadcast address of ETH0? So for this, it's easier to be logged into the server. So ETH0 broadcast address is listed here. The broadcast address is the address that the CS server would send to everybody on that subnetwork. Same question on Y1. If you log into Y1, there's the broadcast address. It's 102.55.255. Number 18. What is the acronym of the network protocol used to transport website and email? So website traffic is HTTP on top of TCP. Email is SMTP or IMAP on top of TCP. The thing in common is TCP. And I didn't want you to say TCP/IP, so I said don't include IP. Default TCP port used for website traffic is 80. And if you weren't sure, you could find various lists. This one on Wikipedia will have all the answers. The other ones should have the same list of numbers. Well-known ports. 80 Hypertext Transfer Protocol. That's HTTP. Maximum number of bytes in an IPv4 packet. You could look this up. It would be in the Wikipedia page about IPv4. 65,535 is because the length of the packet is specified in 2 bytes. 2 bytes is 16 bits, and the highest number you can specify in 16 bits is this one, which is the same as 2 to the 16th power minus 1. That's the highest number you can specify in 16 bits. What is the minimum number of bytes in TCP header is 20. You just look that up. Look at the stuff that's required. Same thing, IP version 6. You look up the stuff that's required. 40 bytes is the minimum, and that's mostly because the address, source and destination address, is longer. Minimum number of packets that must be transferred between client and server for a single packet to be properly received. So if we look here at, this is when I made a request to CNN, there's a synchronization packet that goes from my computer to CNN. There's a synchronization and an acknowledgement that comes back from CNN to my computer, and then there's an acknowledgement from my computer. So those 3 packets are just to get things started. So that's I said here, synchronization, data, and acknowledgement. That's the synchronization, just to establish a connection. And then you would have at least 1 packet of information, and then an acknowledgement. So there always needs to be at least 1 acknowledgement after the data. So that's 3 to get the connection started, and 2 for 1 for the data and 1 for an ACK. And depending on what you want to do, so in this case I did a GET and CNN responded, so I'd actually need more because there's information going both ways, from my computer with the GET and from CNN with the 301 message. Okay, so but 5 was the absolute minimum. 24, the smallest number of bytes in an IPv version 4 header is 20. Just look that up in Wikipedia. 25, standard port used for telnet. So if you just say telnet without specifying the port, it goes to port 23. Alright, that is the answers to these questions. And this is all, if you want to look in the notes, this is all review from the information that's been done in basic Linux, Unix, and basic networking, and homework 0, 1, and 3. And then in your course notes, that is basics of networking, and also a little bit of, only really basics of networking.